Hello friends, myself Rajendra Mahajan presenting my video on solution of differential equation by Laplace transform. Let us solve the problem. Solve by Laplace transform. Equation is y double dash plus 2y dash plus y is equal to e raised to minus t, and the conditions are y at 0 is equal to minus 1 and y dash at 0 is equal to 1. And as it is linear differential equation of order 2, to solve it by Laplace transform, we have to take Laplace transform on both the side of the equation. Taking Laplace transform of both sides, we get Laplace transform of y double dash plus 2y dash plus y, and that is equal to Laplace transform of right hand side term e raised to minus t. Individual Laplace of left hand side term, that is nothing but Laplace transform of first term y double dash 2 times Laplace of y dash plus Laplace of y, and that is equal to Laplace transform of right hand side term e raised to minus t is 1 upon s plus 1 as per the standard result. Then Laplace of y double dash result is s square y bar of s minus s into y of 0 minus y dash of 0 2 times Laplace of y dash is s y bar of s minus y of 0 and plus Laplace of y is y bar of s, and that is equal to 1 upon s plus 1. Then collecting the terms of y bar of s in one bracket. Therefore, there are 1, 2 and 3 terms. Collecting in one bracket, we get s square plus 2s and plus 1 into y bar of s is equal to 1 upon s plus 1. Transferring other terms to right hand side by using the initial condition or substituting the initial condition. The value of y of 0 is minus 1. That minus and this minus, it becomes plus s. When we transfer, it becomes minus s. Y dash of 0, value of y dash of 0 is 1. Minus 1, transferring, we get plus 1. And 2 times y of 0 with minus sign. Therefore, y of 0 is minus 1. Minus minus, it becomes plus. Therefore, plus 2 transfer to right, we get minus 2. And then simplifying it, this s square plus 2s plus 1 is perfect square of s plus 1 whole square into y bar of s is equal to 1 upon s plus 1, and 1 minus 2 is minus 1 and minus s. Taking minus sign common, we get s plus 1. And therefore, it is 1 minus, cross multiplying it, we get s plus 1 into s plus 1 as s plus 1 whole square and divided by s plus 1. Dividing by s plus 1 whole square throughout this, we get y bar of s is equal to 1 minus s plus 1 whole square whole divided by s plus 1 into that s plus 1 whole square, it becomes s plus 1 whole cube. And then taking separate division, we get 1 upon s plus 1 whole cube minus s plus 1 whole square divided by s plus 1 whole cube. Remaining term is 1 upon s plus 1. Next step, take inverse Laplace on both sides. Therefore, inverse Laplace of left hand side, inverse Laplace of right hand side term. Inverse of left hand side is y of t. Inverse of 1 upon s plus 1 whole cube. By shifting theorem, it is e raised to minus t inverse Laplace of 1 by s cube minus inverse of 1 upon s plus 1 is e raised to minus t, and therefore it is e raised to minus t inverse of 1 by s raised to 3, where 3 is a positive integer. It is t raised to 3 minus 1, that is 2, and divided by 2 factorial, and minus e raised to minus t. E raised to minus t common. The remaining terms are t square divided by 2 minus 1 as the required answer or the required solution. One more I will discuss in my next video. Please like my video, share it, as well as subscribe to my channel. And if you are not subscribed yet, please subscribe it. And to receive the notification for my such type of all new videos, please press the bell icon. Thank you. Thanks for watching.